Today, we're going to talk about Lesson 3-1, Graphing Linear Patterns. The big idea is today, the constant increase and constant decrease situations lead to linear graphs are represented by linear equations. So what we're going to look at is how to make a linear equation based off of a constant increase or a constant decrease situation. Now, what you need to know, a constant increase has positive slope. That means it goes up from left to right. Okay? A constant decrease has negative slope. This should be review, which means its graph is going to fall from left to right. Now, on a coordinate point, we also have a point that we normally know how to graph on a problem like this, and that is the y-intercept. Y-intercept is where the line crosses the y-axis. Okay, this is my y-axis right up here. Now, why is that point important? Well, normally in a constant increase or a constant decrease situation, that's normally where your problem started at. Okay, you had so many of this, you gained so much, so it started here, and then you gained so much, so it went positive slope. Or it started here, and maybe your lake drained, so then you start losing water or whatever. Okay, so that point is normally important too. This is called the y-intercept. Okay, and I normally just write y-int. Okay. So moving on. Constant increase patterns. The size of Stefan's coin collection described on pages 128 and 129 increases by 10 coins each week. So he started with so many coins, and then it grew 10 coins each week. You can look at that on page 128 and 129 if you would like. It provides an example of a constant increase situation. Because his collection grows by the same amount each week. Okay, that's a constant increase situation. It grows by the same amount each week. How much did it go up by? Well, it went up by 10 coins. The graph of every constant increase situation consists of points that lie on the same line. Points that lie on the same line we call collinear. Okay, you need to write that down. We call that collinear. Points that lie on the same line are collinear. They will also have the same slope. But notice the graph does not include every point on the line. Because Stefan receives coins at specific whole number intervals, the domain of W is a set of whole numbers. It does not make sense to connect the points on the graph because the numbers such as 2.5 are not in the domain of W. So when we are graphing these, okay, you would just see points that were going up. And why were you just seeing points that were going up? They're not connected because you cannot have 2.5 weeks. Okay? The domain is the set of whole numbers. Okay? So they were only measuring by at the end of each week. So 1 week, 2 weeks, 3 weeks, so on and so forth. They weren't measuring halfway through the week. Okay? Constant decrease patterns. Constant decrease situations involves a quantity that decreases at a constant rate. In example 1 below, the variable can be any positive real number between two whole numbers. The graph is no longer a set of separate or discrete points. It is connected or continuous, and we're going to look at that here in just a second. A discrete set would be our whole numbers, 1, 2, 3. It can only be a certain number. Okay. In this next example, example 1, we're going to show how it's continuous, or where the line is going to be connected. Okay. If you look at example 1, after a flash flood, the level of water in a river was 54 inches above normal. and dropping at a rate of 1.5 inches per hour. Let x equal the number of hours since the water started dropping, and let y equal the height, in feet, above normal of the lake. We can model this situation with the equation y equals 54 minus 1.5x. Graph this relationship. Okay, well, first of all, what I'm going to do is I'm going to plug in some numbers for x. And I'm going to plug in easy numbers for x. So I'm just going to make a table here. Now, what you could go ahead and do is you could put this in on your calculator. Yes, that's why we have those calculators for. Okay, but I'm going to show you how to do it the hand way. Okay, so I need a number that's going to go in for x. So I'm going to pick an easy one. 0. 0 times anything is 0. So 0 times 1.5 is 0. 54 minus 0 is 54. Okay. I'm going to start making the graph here, even though I have it on the next slide, because I'm going to show you how easy this is to draw. So here I got a point, right? It says my x is 0, my y is 54. So I'm just going to make 54 clear up here. So when x is 0, that's right here, y is 54. So there's a point. See how easy that was? I'm going to put 1 in for x. Okay? When I put 1 in for x, then what happens is 1 times 1.5, if I put 1 in here, 1 times 1.5 is 1.5, so 54 minus 1.5, you all are going to tell me is 52.5. Okay? Very simple. I'm going to graph that. So I go over 1 unit, and I'm going to go up 52.5. So I'm going to say 52 is right here, and 52.5 is going to be roughly about right here. So 1, comma, 52.5. I'm going to put in another number, 2. If I put in 2 here now, 2 times 1.5 is 3. 54 minus 3 is 51. So I got another point. 2. And 51 is just 1 below that. So if I say this is 50, 51 is going to be right in the middle. And I know my graph ain't pretty. But these 3 points would all be on a line. And notice it is a constant decrease problem because it's falling from left to right. Yes, now like I said, my picture's not very good. But you could also type this into your calculator, and let me show you that real quick. Sorry I don't have it pulled up. You're going to have to give me 1 second here. But all I have to do is type this into my y1. This y equals 54 minus 1.5x. All I have to do is plot that into my y1. And I'm going to show you how easy that is. So if I type in 54 minus 1.5x, okay, I hit graph. As you can see, I can't see my 54. Why can't I see my 54? Well, I didn't make my window big enough. My window has to be at least on the Y max 54. Yes, you're going to run into this problem. So let's make this 60. Then I can see it. If I hit graph, there's my line, okay? This went through 0, 54. If you look through here, all these points are collinear. Okay? You could go find all these points if you wanted to. Or I could go to my table. Second function table. 0, 54, 1, 52.5, 2, 51. I found those 3 points, right? So you can do it by your hand. You can do it by your calculator. Which one's easiest for you? Okay? So let's look at this graph because the book gave me a better graph. But if you notice here, here's my y-intercept. Your y-intercept is found when x equals 0. So 0, 54. So my y-intercept is 54. That's where we started at. 1, 52.5, so on and so forth. Notice how we connected the lines because it is a continuous function. Excuse me. Example 2. In example 1, if the water level continues to drop at the same rate, how many hours will it take for the water level to fall to 3 feet above normal? Well, if you notice back here, we are going by inches. So what's 3 feet in inches? Okay? That's what we need to change first. Well, 3 feet in inches is 36 inches. Okay? Now, what you need to ask yourself, what's changing? Is my y or my x changing? Well, if you remember from the graph, this was height, and this was hours, right? So is my height or is my hours changing? Well, we want to know when it gets down to 36 inches, so I would consider that a height. So we want to know when y equals 36. So here's what you need to do. On your graph, okay, make this your y2. You keep that function the same, or that line the same. Leave your linear equation the same because you want to know when this equation equals 36. So on your y2, what you do is you go down here and go to 36. Now, what's going to happen is you're going to have a horizontal line at 36. Okay, so let's say this is 36. Y equals 36. And then what you have is your line that is descending at some point from 54 all the way down because it's decreasing by 1.5, right? And these two things are going to intersect. And when they intersect, you're going to get an x comma y value. Well, your x is going to say how many hours it takes to get to this point. So let's do that. So I'm going to hit graph. Now, what might have to happen is I might have to change my... See, it's past 10 here. So what I'm going to have to do is go ahead and move my X max out. So I got to change my X max to at least 15. I hit graph. Notice they intersect right there. Now what I could do is I could bring my cursor up. And I could scroll clear over here. And as you can see here, my x is approximately 11.8. Now notice my y ain't exactly 36.2. It's 36.2. It's not exactly 36. So that could be rounded down a little bit, maybe 11.6, 11.5. Okay. If you wanted an exact value, so you could say, how many hours will it take for the water level to fall to 3 feet? You could say about 11.6 hours. Okay, now moving back here, I could probably get more of an exact answer if I went to my table. Okay, and we want to know when these two things equal 36 together. So I got to scroll down here. Ain't the calculator fun? But if you notice right here, it's going to be, sorry, I should have left it at 11.8, right? My bad. But if I look here, my table gave me a more exact answer, correct? Yeah. When this equals 36, notice when this function equals 36, then it equals 36, okay? Then my x is 12 hours, so my exact answer is when it is at 12 hours. Okay? So this I got from my table, this I got from my graph. Your table is normally going to give you more of an exact answer. Okay? I will take this answer. I realize getting it off your graph, a lot of people like to do, so I will take this answer. About 11.8 is really close to 12. Okay? It's just that on your table, you're going to get the exact answer. You can go all the way down to the decimal point, and we can show you that after a bit. Okay? So, very important thing to know how to do. You're going to be doing this the rest of your math career. Okay? Here's another graph that the book used. Notice they have the graph from 54 all the way down, went clear out there. Here's where 3 feet's at. And they did the same thing as we did. They went to see where it intersected at. It intersected at the x value 12. Okay? Hope you enjoyed this lesson. There's going to be many more things of this to do throughout your career. We need to know that you need to know how to use the calculator. Please use it to your benefit. Thank you very much. We'll see you tomorrow.